Hello everyone. So today I'll be participating in this AtCoder Beginner Contest 382. Uh, so let's see what happens. Okay. Okay, let's go. Daily cookie. Okay. So it says there are n boxes arranged in a row, and some of these boxes contain cookies. The state of the boxes is represented by a string s of length n. Specifically, the ith box from the left contains one cookie. If the ith character of s is this, it is empty. This. Over the next d days, Takashi will choose and eat one cookie per day from among the cookies in these boxes. Okay. Determine how many of the n boxes will be empty after d days have passed. It can be proven that this value does not depend on which cookies Takashi chooses each day. It is guaranteed that S contain at least d occurrences of at the rate. So we have been given the string of length n, specifically if the ith box from the left contains one cookie. Okay. So let's take the input. And then I have been given this string. Okay. Left contain is at there, and if it is empty, if it is dot. Okay, over the next d days, Takashi will choose and eat one cookie per day from among the cookies in these boxes. Okay, determine how many of the n boxes will be empty after d days have passed. Yes, at least contain d. Okay, so I guess a simple iteration should solve this. I greater than b 0. I can break out of this like 1 2. How many of the n boxes will be empty after d days have passed? Does not depend on which cookies the cast. Okay, so 1 2. Okay, I'm not understanding. Especially the ith box from the left contains one cookie. If the ith character is this, over the next d days, Takashi will choose and eat one cookie per day among the cookies. Okay, among the cookies in these boxes, determine how many of the boxes will be empty after d days. So he can eat any cookies, or there is any order? I'm just thinking about that. There are cookies. He chooses the cookie on the second. Okay. Okay, I can eat any cookies. So dot is 1 2 3. I will eat 4. cookie count. Uh, C count plus equal to S of I equal to at the rate. Okay, I got cookie count. Ans will be, so I can initialize with n minus C count, and I will be doing ans plus D. Seven. I mean, you can always eat cookies, and it is saying that it's going to contain at least D occurrences of this. So I guess it should work. Let's see. Okay, so the problem is you're required to find different. Okay, okay, got accepted. Cool. Same question. This determine for each n boxes whether it will contain a cookie after D days have passed. What? Okay. Is there any order? First day he chooses the cookie in the. Oh, okay. Over the D days, Takashi will choose and eat cookie one per day among the. On each day, he chooses the cookie in the rightmost box that contains a cookie at the end. Okay. So Miller, but I will be traversing right, and let's say B greater than 0. Yeah. If I S of I this, and in the end I will just print as okay. I will just print as one for each one. From the right he will start eating, so this, then I can mark this I, that's it, dot, and I can decrement D. Cool. This thing. He accepts. He accepts, bro. He accepts. Done. See, there are n people numbered from 1 to n visiting a conveyor belt sushi restaurant. Okay, the government. Okay, I don't know whether I'm spelling it correctly. Government level of person I is A of I. M pieces of sushi will be placed on the conveyor belt. Okay. The deliciousness of the Jth sushi is B of J. Okay. Okay. Each piece of sushi passes in front of people 1 to n in this order. Okay. Each person, when a sushi whose deliciousness is not less than their government level passes in front of them, will take and eat the sushi. Okay. Condition is for each person. Okay. When a sushi whose deliciousness, okay, whose B of J is not less than, which means is greater than or equal to their government level. Okay. Okay. Government level in front of them will take and eat the sushi. Otherwise, they don't do nothing. Okay. A sushi that person I takes and eats will no longer passes in front of person J. Okay. We are starting from this. Here is ith person. Here is jth person. If that person eats the sushi will not be given to this person. Okay. For each of the m pieces of sushi, determine who eats that sushi or if nobody eats it. Okay. Everything is n. Okay. N M N M N. We have been given A of N, B of N for auto, L in A for auto, B, L. Okay, I got AI and BI. So some kind of pointer approach I have to take. Let's say my I pointer is pointing to 0, J pointer is pointing to 0, I pointer is for N, and J pointer is for M. Here goes I, here goes J. Or I can decide the position later, let's say. And in the end, I have to determine which person needs which sushi now. Store an answer of M. So I have to return this M. Okay. There are M lines I have to input. Okay, cool. So in the end, for auto, LE and C out LE. Okay, cool. So 7 3 8 2. So first 5 will be given. Okay, for 5 no, so 5 will be eaten by 8. Skip, eat 5. So okay, so it is. If the deliciousness is not less than their government value, okay, so 5 3. Okay, 3 3 1 2 3. 5 is more than this, so this person will eat. For 2, this will not eat, this will not eat, this person will eat. And for 1, less than this, less than this. Less than this, so this will not eat, this will not eat, this will not eat, so -1. Okay, so how to find this? Is the first index which is smaller than this. How to find this? Which is the smallest index, which is smaller than this on the left. So it's the first index. Constraints are like this: 2 times 5. Okay, what if I short this? If I short this, okay, I cannot change this, but I can change this. So this will be 1 2 5. Now for 1, I can check, or let's say for 3, I can check the last value. Okay, last value is 5. Okay, so person 3 will be eating 5. Eating 5. Okay, so 5 will be by person 3. Then for 8. 8 also 5. No, reverse thinking. So I don't think. What to do? The deliciousness of the jade. So she's beauty. How to find this? The first index on the left. First index, which is smaller than, let's say, t. How to find this? I thought I could solve it in 2-pointer. So for each one I need small one. So if I start from left, 3 is the smallest one. Then 3 again is the smallest one. Then I got 2. Then I think this is given. Zero clue. Let's look at D. Okay, this looks interesting. think some backtracking is required here. You're given n and m, print all integer sequences a1, a2, an of length n that satisfy the following condition. Okay. Satisfy the following condition in lexicographical manner. Every a of I is at least 1, ai minus 1 plus 10. Okay. ai plus 10 less than equal to a of I for each integer I through 2. And 2n. Okay. And a of n is less. Okay, we have been given as a normal. N is 120. Okay, 120 minus 9. Is between this. Is there any math I can do? Some math. Run 3. Every sequence is this. 23. I've been given 1. I don't know this. Let's start from the start only. So plus 10, so 11 at least. Okay, that's why 11. All the elements should be this. So I have so okay. What's this? Oh, okay. The last element should not exceed n. The last element should not exceed m. Okay. So if I try to some kind of recursion. So if I'm starting here, this should be like plus 10 of this now. So if I start from m here, this should not exceed m minus 10. Yeah, these are sequences. Yes, these are list of elements. So this should be at least m minus 10 minus 10. So twice, and like this I will go right minus 3. So starting from this, some kind of m minus 10 and minus this index. Okay. This was the number. So I just need to backtrack, right? Okay. This should be simple. And the standard DFS I will be applying. Okay, so any other thing? Okay, I have to input size of this. I guess this is doable. Okay, so I have been given an m. Okay, now let's do vector vector of ints. Yes, everything will be int. So my sequences, and I don't need curl sequences, so this should store my answer. And I can do something like a yeah, this will be somewhere at DFS. Okay, so it will be taking my position, and I can make this and here. I don't need this. Okay, so this is my position, and what I will be needing is, yeah, I will create a my current sequence, sec. Yep. Whenever my index is exceeding my n, so whatever sequence I'm getting, so I can push that and to return from this. Okay, now so this is one. Now then there is this iteration. Okay, so if I'm at the ith position, okay, so val, let's say val, so this will be m minus 10 times my n minus cos. Okay, then I'll be needing somewhere Okay, now how I want to do this. How I want to do this. Maybe for I. Okay, I'm here. I should stop if I cannot make anything right. Okay, I'm using this and this and okay, so what is my beginning range like this to this? Okay, so this something like uh this. Now how to decide this? So mm, mm, up to what I can go, to what I can go, right? Uh, AI extend, right? And this is valid for everything. This okay. Okay. Okay, if I'm not hitting my first position, if I'm hitting my first position, then one. Otherwise, whatever will be my cursor, I can use this. Then okay, and this will be my L, and I will be doing this R and one more condition. This okay, and I plus plus. So okay, now this element I will be putting in my current sequence. So this will be my what will I this? So this will be yeah. But then I will again call the DFS on this with the next sequence, and so yeah. Okay, I guess this should do. And then yeah, I'll just simply call this here. First I have to empty this. So sex this should be clear, and yeah, so I'll be calling my function with one, and yeah, yeah, from the first position I will try, and then I will move to with a empty list. Okay, now this should populate my sequences, and yeah, for auto, and yeah, so whatever sequence I got, so see out sec this, then auto sec. Okay, now this, then for auto auto le my sec every count. Okay, now use this. space separated. Okay, and again, new line. Okay. Right, let's show to. Boom, 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 boom. And 95. Please. Error. End was not declared in this scope. Something with this. For auto-really in sec. Sec is this. Okay, that's for doing this. Okay. Okay. So. And be here. Okay. This is this. Yep. 13, 13. Okay. Any other test case I have? Sure, what have any test case? Okay. Last one. Okay, cool. Nice. Twist. Okay. Cool. Should I turn this? I'll look at the next problem. Okay. There are infinitely many packs, each containing n cards. In each pack, the ith card is rare with a probability of P of I percentage. Whether each card is rare is independent of other cards being rare. Okay. Looking at the constraint, I can say that this should be a DP problem. Just a second. How much we have? Okay. Really like it. Infinitely many packs, each containing n cards. Okay. In each pack, the ith card is rare with a probability of Pi percent. Okay. whether each card is rare is independent of the other card being rare. Okay, cool. You will now open packs one by one. Now open the packs one by one and obtain all the cards in each opened pack. In each opened pack, huh? You will now open the packs one by one, okay, and obtain all the cards in each opened pack. Each card is rare with probability of P of I, each card is rare independent. Okay, when you keep opening packs until you have obtained a total of at least X rare cards, find the expected number of packs you will open. Have no fucking clue. I have many packs, and each of them contain N cards. Okay. The ith card has a priority of P of I, and P of I is given. Okay. Let's think. So every pack has the same probability. So for example, I have two cards. Okay. And expected priority is xi pi, right? Xi pi, that's the expected probability. And so 50 days in 100. Okay. So whatever I got, I have to divide it by 100. Sorry, this is summation, right? And what's the issue then? Until you have obtained at least X. Until I have obtained at least X cards, and X is also given. So, it's like increasing the probability, right? Here 40 60. So until like the number of packs opened will be 1 with the probability of this, and 2 with the probability of half. having a card I know that is this is normal binomial. This Zabernoletrans. Poisson, if I remember, discrete and leaves a time. Expected number of packs. So I believe this is because in this one of the pack, okay, if I want to compute what's the probability of getting an X number of rare cards, it's similar to like asking within this time what's the probability of getting 5 requests. It's Poisson for you. Okay. Then how do I compute the expected number of packs? So this will follow Poisson, right? Then how to compute this? How do I compute the expected number of cards? Okay, so I have two cards. One has a 0.5 and one is one. So, how many draws I have to do in order to get at least two rare cards? So, if this card is rare, then I have already got it. Now, if this is not rare, I have to again, then I have to do two packs. This is then one pack. Is the get this and this, right? Hmm. There is the probability of what the fuck is this? Way of getting in the first pack itself. That is there. Then hmm. So P of getting this in the first pack. Okay. This I know I will get, but to take these events, right? So if I am getting in the first pack itself, that's 0.5 for me, and I'm going via contest. Then pack 2. So to what pack I have to go, that will determine this. Yeah, that is my answer. And here the probability is also 0.5. Reason being, I'm getting this, but happening of the second, yes, and cool. So for this one pack I have this, for pack 2 I have this. So this will result in yeah, pack 1, pack 2, so 1 times So this will be 1.5. Okay, 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 okay. I'm getting this. Similarly for this 40 and 60. So I have 40 and 60 and I need to access 3 now. Yep. So sorry about this. Then okay. So I have a 40% chance that this is that, and I have a 60% chance. This. So what's the probability of getting in pack 1? That is 40 and yeah, 40 times 60. That's 24%, right? Yep. Then second. Second pack, I have the 2 packs. Okay. Each pack has this. Okay. Okay. No, 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 no. Let's look at see. Yeah, so then A and B. Right. Think of that. Okay. I create the min index array. And I have people and their index, right? I need some kind of a shortened mechanism. Okay, so I have 3, 1, 2, and 2, 3. How can I do this? How can I do this? Okay. I have some kind of this. I have some kind of this that can tell me what's the minimum. All those indices. Okay. Now if I short them, this will be first, this will be second, this will be this. So I'll say like 3 will come here. Okay. Now 3 will come here, obviously, because of this. This is my index. Then if I say which is the minimum, this and this. Okay. For this position, this will be, I will be comparing 3 and 1. 3 and 1, so 1 will come here. And then for the next index, which is 2, then 1 will come here. Okay, this is the minimum. Okay, now what I can do is I can apply a binary search on this. Yes, because this will always be shorted. This will always be shorted, right? And from this I can always get the minimum index. So if I ask 5, now for 5, if I apply the binary search, and since this is indices are shorted, now if I find the position, first position here, will be this. Now for this position, I can take this. Okay, and then I can look for other candidates on the right. Okay, let's try this. In left. So it will be I pair min left. So for 0, min left of I, or yeah, I can do put back of a of I and a plus 1. Okay, then sort them respect with the first value, right? So min left, this will not be min left. I will be creating this list, so it will be let's say some p So smallest person will come first, then this, then this. Okay, then once I short this, then what I can do is now I can build a min. So min left, this will be of size n. So it can act as my prefix. So left of 0, no, my p of 0, and this will contain the index p of. Okay, now this, now I can answer for every b. We'll consider this for the sake b. Okay, now this I got, and binary search and index. Okay, -1. This I can if p of mid. Okay, now if p of mid, whatever index I got, now this of first is less than my j, which is le. Now this is a possible answer. So index will be storing in mid, and I will try to check for the leftmost one, which will appear on the right. I'll go to mid +1, and I'll go to mid -1. Okay, now see out my index equal to -1, then I can return -1, otherwise I can return index. Associated with which person? So this will be p. Okay, let's F. Predict per. Okay, let's focus on the math. Is the probability of x being 0? Then I can ask more specifically. Are this related? Yeah, just a summation, right? X expectation is something like this. Right? Now for text. Not think. Uh, I like code it. I think about within this distribution. What's the probability of getting one rare card? What's the probability of getting two rare cards? What's the probability of getting three, four rare cards? Then I can do some kind of expectation. N cards. So now to compute what's the probability of getting at least k rare cards. Rare cards. And I can initial, this will be again double. Okay. I need at least x, and everyone is 0. Um, then what's the probability of getting 0 rare cards? So what's the probability of getting 0 rare cards? It will be getting 1 rare card. This will be a chain, right? Yeah, this will be a chain. So like this can be a rare card. This can be a rare card. Something like this now. They will be contributing. Okay. So I then J equaling X then J now starting with this previous one I made. So PK P P of K of J. This will be my current P times my P of I, and I need this incrementation also, right? I have this, need the summation also, right? So this summation. How do I get the summation? simple binomial distribution calculation, right? Okay, so somehow I figured this out. Now, I'll be doing summation of expectation, right? And I will be updating my expectation. So I will start from this one. I then mm, once I have this for all the states, uh, expected back one is there. This back count. I cannot think of anything. Yes, that's all. This 100. Too much maths is involved here. Hmm. I can't read. I'm still like thinking about problem how to solve that. So for each pack, if I compute, what's the probability of getting this k number of cards, k number of rare cards? Now I can use that information to compute the expected number of packs. Okay, this is given. How do I compute this? So that is one rare card among n cards, right? So something nc1. So this is when we do in coin toss, right? 1 minus p and 1 and p minus 1. So here probabilities, those things are given. So how many ways I can have? This is easy because every one of them is 0.5. This is a bit complicated because we have been given a distribution. 6 now. Hmm. Okay, contest has ended. Let's see. Okay, tourist. Oh, tourist conditional G. Some insane speed. uh, okay. Mm, okay, cool. Uh, so okay, guys. So I'll be uploading this video in my channel. You can watch screencast here. I feel bad. I was not able to solve E. Hmm. Yeah, but what can we do? This not my day. So cool. Just stay tuned to watch more videos. I will be participating in. So I am participating. I will be participating in more contests, and I will be uploading more screencasts. Cool. So I hope you guys learned something new, and yeah, just stay tuned to watch more videos.